Leo,
Yes.
I can't hear you very well. Can you? Okay, wait. So, Leo in general, and this is very popular for people who wear smart glasses, especially blind people. This segmentation is a way to analyze every object in the image. Of course, this goes by checking each pixel and categorizing them. So it will say, oh, I see in this image a table, a chair, a car, a house, a door, a window. So that is segmentation. So we make a circle. So typically, if we have an image like that, okay, so you will find that this is normally done in Python, not in Java, but anyhow, this doesn't really matter at the moment. So so I have, let's say I have this object one and object two like that, and object three. So typically, if we are passing this information to human, so this segmentation draw like a kind of rectangle around the object, and not only so it located in the image. Not only that, but the segmentation works on telling, oh, it will write here table on top of this rectangle or even square. Here maybe window. Here maybe a door. So everything that it's able to recognize on the image that it receives, it will analyze it, segment it into a category, so that what it looks like. Okay, if you are in a traffic light, um, this kind of segmentation is able to tell how many cars even in the scene or the image that is taken, and then you are able to count the number of the cars. Okay, does this make sense to you?
Yeah.
Okay. So certain countries equip their police people or policemen with a smart camera. I think China is popular with that. It's so much advanced. So you will find most probably that many of them are wearing smart cameras that is able to do facial recognition, which means that it is able to just by looking into your face or seeing your face, they are able to retrieve all the information related to you. Are you required? Are you um, they have social ranking based on numbers and the behavior of the person in the country. So all this information can be even seen by the policeman in the smart camera. Is smart, yeah, smart glass that he's wearing. It's not related to this, but it is a kind of image segmentation. Leo, are you
Yes.
stuck? So stories normally stick to the human mind more than just bare academic information. So that's why when I tell you a story like that, I hope that this can make the information stick in your mind and then you remember it by the story. Excellent answer, Leo. Excellent.
Modules, which just feel like the steps in the process of the algorithm.
So we have actually five modules in the VSLAM, and two of them is supplemental. Okay, so you can say as a start, tracking is a module, and then there is another two, and there is two you can say supplemental. So can you start recording or?
Tracking, method,
Second, we can say local mapping, loop closure. This is also one of the modules inside the VSLAM. And there is another two that is supplemental. So we have relocalization and we have global map optimization. So all of this, the five modules in the VSLAM algorithm. Do you know the function of each? The question does not need to you to answer that, but do you know the function of each?
yes.
Okay, then you can proceed. So no, because this was a question actually here. So my question to you is, first define what is a global map optimization, and then define what is a loop closure. Yes, I know that you already mentioned the loop closure somewhere here, that it takes care of the drift. But that is, I want you to look from far. This is um, far away, or an overview of how what is both. So what is the output of a global map optimization?
It's like it increases the accuracy of the map itself.
Okay, okay, that's good. And so if we have, so normally we are drawing 3D maps, right, for the environment
Yes.
around us, right? Okay, perfect. And that global map optimization makes sure that our map is accurate and correct. Am I right?
Yeah.
Okay, perfect. And is it loop closure also depend on images?
Not necessarily.
Okay. But if you use it in the VSLAM, it somehow need to combine with the visual. Okay.
Yeah.
So I would say to you that the global map optimization work on the whole map, but the loop closure actually it helps in finding the current location. So it only work on the granular level. It work on image by image. So this is for the whole 3D map, but that work on a smaller level actually. So yes, there is both of them try to work on improving the map and even the location of the robot, but that work on single images on the granular level. That work on the whole map. Did I make sense to you?
Yep.
Okay.
Does map optimization use a loop closure?
No, map optimization in this specific context does not use a loop closure. So the two techniques that actually work for map optimization is actually two things: bundle adjustment and keyframe selection. So May you define the bundle adjustment as part of the answer for the so you're talking about reprojection error, right? So can you first define what is the bundle adjustment?
Bundle adjustment would make it increases accuracy through multiple images, through using multiple images.
Okay. Yeah. Okay, that's good. So if we have an object that is in 3D, assume it is this object, and then you have multiple cameras. So each one of them is actually seeing different paths. So this is here, and assume that is we are looking here. So part of the bundle adjustment that, okay, we see the object from different views, and then we have images. So typically the image here, no, let me see. So we take an image for every from every camera for the same object, but from different pose actually. So the angle that is mounted on the angle of where the camera itself is mounted on the robot might differ, so that it takes different views of different objects. The point here that every one of these cameras sees the objects from a different angle. So somehow there is errors that occur when we are taking that that object image. So typically you will see that the image that we have from that camera will have 2 points. So one point, we assume that we are actually looking at this object from this point, okay? But in reality, the object is somehow a little bit far from what we are projecting. So this is what the camera see. So I say what we see, but this is the actual. So the point or the method, the mathematical method of correcting correcting the errors that occur when you see the image, different images, take different images for same object from different camera angles. This kind of process or a mathematical process is actually done in the bundle adjustment. So you are trying to draw a 3D image for an object, and there is errors that actually occur, and to correct that errors you use a mathematical model or method to do that, and that is part of the bundle adjustment. Okay, so the reprojection error, this is when you see a 3D object from different cameras and you are trying to actually minimize or how to say, not minimize. So you are seeing the object in a way from the images. You are building or you constructing a 3D model for this object inside the robot itself. Okay, but in reality, that the dimensions and the positions of that object might be slightly different, and this slight difference occurs on every image here that is taken by the different cameras. So the method of correcting that, as we said, is part of the bundle adjustment, and we are always trying to minimize the reprojection error. So that is a mathematical formula that is come with a bundle adjustment. Leo,
Yes.
are you still following up?
Yes.
Did you manage to catch anything? I know that is not so so easy. I know it's tricky somehow, but did you manage to catch anything from what I said?
Yes.
Leo, we have to close and open again.
Okay.